What's up everyone, welcome to your fourth networking tutorial, and in this tutorial I'm going to be teaching you guys about something called the OSI model. Now this is the OSI model, and if you're wondering what this is, it's pretty much a model to help standardize networking. So before, in the old dinosaur days when networking just began, they didn't really have a lot of standards, and communication between different nodes and stuff would be like chaos. Such as like companies like IBM would make a computer and it wouldn't be able to connect with like a Macintosh computer or anything like that. So in order to broaden the range of like stuff like the internet and stuff, they had to come up with something called an OSI model, and this stands for Open Systems Interconnection. I'm never going to be saying that again because everyone always says OSI model, but just so you guys know. So what this pretty much did was allow different companies, nodes and stuff, to talk with different other companies, their devices, and just broaden the range of communication for everyone. So this model is actually useful, and you need to know it because it lets you know how different devices communicate with one another, and it also lets you know things like how devices know when and when not to send data or not. So although you might think this is quite useless right now, by the end of these tutorials, trust me, you will be thanking me for teaching you this. So as you can see, the OSI model consists of 7 layers from bottom to top. And as you can see, the bottom layer is called the physical layer, or also layer number 1. So remember, this is with 1, 2, 3, not 1, 2, 3 like this. That confuses a lot of people. So always remember, because you never know if I'm going to say layer 1, physical layer, or bottom layer. They all mean the same thing. So now that we can see what all the layers are and where they are, let me give you a brief overview about what all these layers do. The bottom layers, and these kind of blend into each other. The bottom layers usually do stuff like transmit data and transmit like frames and packets and stuff, and I'll teach you guys what that means later. So that's what these layers do. The middle layers do stuff like communicate between different computers and stuff. So if I had one computer and you had one, that's what the middle layer would be doing. And the top layers right here, those do things like those are like your software applications, and they present the data to you and include like data formatting stuff. And I know you guys might be lost on everything I just said, but trust me, in a little bit you guys are going to thank me. I'm going to be teaching you guys what the physical layer is today, but if you guys got antsy and want to know all that other stuff, then there it is. But I promise I will clear things up for you as I move on. Now, moving on. The physical layer is the layer we're going to be going over today, and what this layer does is it encompasses all the things like your wired cables, your fiber optics, your radio waves, and stuff like that. Your physical layer also has your network connectors and is your network topology, and that's why it's named the physical layer, since it's the layer of stuff that you can see. So if someone says, alright, there's a problem with the physical layer, it might mean that there's a problem with like one of the pieces of hardware in your network. Now, as you know, all data in computers is transferred from binary code, and this is 1 and zeros. So for example, if you have a code called 10110, this might mean a certain thing to a computer. But if you're saying, alright, how exactly does a computer read this information? Do you just send it like Pineapple Express or whatever it's called? Do you send it in a plane, a bunch of 1s and 0s? No, you don't. To send one set of data to another computer, you have to use one of 2 signals. One is called an analog signal, and this is like signals in waves, like radio waves and microwaves and stuff like this. And the other one is a digital signal, and this is, well, I'll show you later what this is. But let's go over analog signal, and I will shorten that to anal right here. And let me tell you guys what an analog signal is. It's pretty much a wave of voltages that you can send across a network. So for example, this equals 0 volts, this blue line we have right here. Say you have a radio wave that's sending a certain amount of voltage. So your radio wave might look something like this. It might vary a little bit like this. One wave might be higher than the other, but their frequency is always the same. Anytime you have a positive volt right here, and of course these are supposed to be touching right there, I just really suck at drawing, then anytime you have a positive volt, your hardware on your network is going to read a 1. And anytime you have a negative volt, your hardware on your software is going to read a 0. Now this is built into your hardware, and as you can see, this is how analog signals can send 1s and 0s. So for example, if you have a wave just like this one's going to read 1 0 1 0 1 0. But again, your hardware you have can shut off the signal at certain times. So it's kind of like Morse code. You have 1 0 1 1 1 0, and this means something to your computer, and this is like the computer's language. So this is how you send 1s and 0s over a network. But recently, what the makers of networks and hardware and stuff decided to do is they saw that there was a better way of doing this than sending signals over the radio and stuff like that. So they decided to make something called a digital signal. And let me go ahead and view my grid. It might be a little easier. Show grid. There we go. That looks a little better. And they decided that we could do something called sending digital signals. Now what digital signal is a distinct level of voltage to generate 1s and 0s. And this is really common, especially with LANs and local networks and stuff like that. So for example, instead of a wave, whoa, my grid is messing me up. Let's get rid of my grid. Show, how about not show grid there, Bessie? Actually, you know what? That grid is going to be perfect for this. Think again. Alright, so a digital signal, look at that. Look how cool that says digital. It even looks digital. This is so perfect. And I will name that digit for short. That use a distinct level of voltages, such as, say you have 5 volts right here. Oh my god, that is perfect. And 0 volts. And as you can see, a digital signal works a lot different. And again, this is 5 right here and this is 0. So instead of waves that vary, you can send distinct levels of voltage over a digital signal. And another thing you might have is like positive 5 and also negative 5 like this. And as you can see, this one's kind of messed up. But as you can see, this is the difference between digital and an analog wave. And another thing that you guys might be asking about is something called fiber optic. Now this is the fastest thing we have out right now. And to do this, anytime you have a piece of light, it equals 1, and anytime you have no light, it equals a 0. So for example, if you wanted to send the 0 1 0 0 1, you would have a piece of light sent, and then you have 0 0, and then you would have another piece of light sent. And this is fiber optic, and that is also a digital signal. So again, I hope you don't mind my awesome drawings, but those are the basics of how to send binary code using signals, using a digital signal, and also using an analog signal. And as you can see, digitals are a lot more distinct, and they're usually just a lot more precise and better and faster. So that is your networking tutorial. In the next tutorial, I'm going to be going over the next layer of the OSI model. So thank you guys for watching. Make sure to please subscribe to my channel, and I hope you enjoyed, and I'll see you next time.